All right, suppose you have this candy bar. I know you don't want to give the candy bar away, but suppose you gave 2/3 of your candy bar to Rosie, and she gave, I don't think she'd give any candy bar to Mike. But say she gave a half of a candy bar to Mike. How much the candy bar did Mike actually get? Well, to really visualize this and see this happening, let's come over here and I'll show you. All right, I have a really cool problem to go over, but before I do, I just want to introduce you to some new manipulatives so that you understand what's going on here. This is 1. This whole square represents 1. It's a little different than some other manipulatives we use. Let me show you. That means these, each piece here, represents 1/6. Okay, so these are 6th pieces. Okay, so I have thirds, I have 6ths, I have 4ths with me, I have a whole lot of different pieces with me. Okay, so that's what we got. These are 6. Okay, all right, just so you know that that represents a whole. All right, so here's what I want you to understand. Suppose you gave 2/3 of your candy bar to Rosie. Okay, so I'm going to show you that these are the thirds pieces because they will make up the entire whole. 1, 2, 3. Okay, so there's your thirds pieces. Okay, so here's what the question says, right? The question says, suppose you gave 2/3 of your candy bar. So there's your candy bar, but you gave 2/3 to Rosie. Okay, so this is what Rosie has right now. 2/3 of the candy bar. That's what she has right now. Okay? Suppose she gave half of hers to Mike. There's a couple of different ways to do this, but I want to show you this. Suppose she gave half of hers to Mike. So I'm going to go half. Half of hers to Mike. So let's say Mike gets this and this. This is Mike. Okay, I don't really have to keep them together anymore. I want to show you how much Mike got. Okay, ready? Mike got actually 2 of these pieces I showed you before. So Mike got 2 of these pieces. I'm just going to say these pieces. Let's talk about what these pieces are. These pieces are, come back to the original, 6. Those are the pieces I showed you before. So these pieces are 6. So Mike gets 2/6 of the candy bar. So we're going to go back and do this problem by hand. And you might be thinking, you know, because I was even thinking this as I went along, why did she do it that way? Why, when she had 2/3, okay, why when she had 2/3, instead of cutting it in half this way, why didn't she just take half of it away? And then she would get 1/3. So maybe the answer is 2/6, or maybe the answer is 1/3. We'll talk about that. So let's take a look at what we're really saying. We really took 1/2 of 2/3, and we got, as you saw, we got 2/6. Okay? Well, looking at this answer, 1/2 of 2/3 equal 2/6, what do you think we actually did with these two fractions to get this fraction? Well, it appears like, look, 1 times 2 is 2, 2 times 3 is 6, so it looks like we multiplied. So now what we know is 1/2 times 2/3 is 2/6, and what we really know, which is really important, is that of means to multiply. So now we have another keyword. Of tells us to multiply. All right? And now what we would do is we probably would reduce this fraction because we like to have our answers in reduced form. So I'm going to take 2/6 and I'm going to reduce it. So we got to pick a number that divides into 2 and 6 evenly, and that would be the number 2. So 2 divided by 2, 6 divided by 2, and I would get 1/3. Okay, so the answer to that question is Mike gets 1/3 of the candy bar. Okay, let's take a look at another question. Okay, I'm just going to show you how I would take care of the sign first here. I would go, well, we have a negative times a negative. Signs are the same, so the answer is positive. So right away, I know the answer is positive. Now, it's up to you whether or not you want to reduce. You may not until you get used to it. It's absolutely up to you. But 3 times 1 is 3. 7 times 9 is 63. I can reduce this. The only problem with not reducing at the beginning is you may have to start working with very big numbers. But that's up to you. Okay, now I reduce. and I get 1 over 21, so 1/21st, okay? If you wanted to, you could have reduced. I'm just going to show you one more time how you would have reduced this, okay? Just one more time, and then we'll go to the other problems, and then you get to pick your own poison. Do it whichever way you want. I can reduce this way, diagonally, or up and down. 3 goes into 3 once, 3 goes into 9 3 times. I know my answer is positive, because they're both the same sign. Don't worry about the signs now. 1 times 1 is 1. 7 times 3 is 21. Doesn't matter how you do it, whatever you like. The only problem without reducing first is that you may deal with big numbers. But with reducing, some people think it's sloppy. Absolutely up to you. Let's take a look at this next question. All right, since obviously not reducing is just obvious, you just go straight across and then you reduce. What I'm going to do is I'm going to do these all by reducing, okay? So there's nothing actually in this problem that I can reduce because I can't reduce this way. There's nothing in common this way. There's nothing in common here, nothing in common here. So I have no choice but to go numerator with numerator and denominator with denominator. And that's 9/40ths, and I'm done. So that's the answer to number 2. Number 3 looks like, I like this one. This one looks really fun. Okay, we have a positive times a negative. That's going to be a negative because the signs are different. Now I'm going to disregard the sign altogether. Now I can go, remember, up and down if I want, or diagonally across because I have to go numerator with denominator. Okay, I'm going to go that way. 10 goes into 10 once. 10 goes into 20 twice. Okay, 7 goes into 7 once. 7 goes into 7 once. And then we just multiply. 1 times 1 is 1. 1 times 2 is 2. So that's -1/2. All right? 1 left. Let's look at this problem. Question number 4. Oh, it looks a little different, and the numbers look really big. I am definitely going to reduce here first. It'll just make my life a little easier. And I'm hoping this will show me everything I want to show you. Here we go. Number 4. 27 over 32 times 10/30ths times 16. Okay. First of all, you have a whole number here. If you're multiplying fractions, you've got to make everything look like a fraction. So I'm going to do 27 over 32 times 10/30ths times 6. Oh, look, 3. This is going to be so much fun. 16 over 1 is 16. Watch how I'm going to do this. I'm going to take care of this right away. I'm going to reduce this number, this fraction. I can always do that because I'm just reducing a fraction. Numerator with denominator. 10 goes into 10 once, 10 goes into 33 times. Okay? Now, I can either reduce up and down if I have a comment, or I can go this way. I can go from here to here. Oh, so you can jump that, guys, like a chess move. 16 goes into 16 once, 16 goes into 32 twice. 3 goes into 3 once, 3 goes into, so even though I reduced and got 3, I can still use them again. It doesn't matter. Okay, 3 goes into 3 once, 3 goes into 27 9 times. And now it's all attached by multiplication. 9 times 1 is 9, times 1 is 9. Over 2 times 1 is 2, times 2 is 2. We get 9/2. That is reduced. If you'd like to change it to a mixed number, you can, but you don't have to. You just have to reduce it, and it is reduced. So you're done there. All right? It's pretty simple once you get used to it. But again, you have to know your division rules. You have to know what numbers are divisible by what numbers. Okay, let's take a look at some other ways they can ask you to multiply. All right, find 3/4 of 36. Well, this of tells me to multiply. So 3/4 times 36 over 1. If you'd rather use a parentheses, it doesn't matter. Okay, I'm going to reduce. 4 goes into 4 once. 4 goes into 36 9 times. 9 times 3 is 27. Later on, we're going to look more closely at this of. Okay? All right, so that's 27. Let's look at this one. If we think about what we've done already, I don't know, about 6 or 7 times, we want to know if this is a solution to this equation. If this is a solution to this equation, it must make the equation true. So we're going to substitute it in and check. Remember, when you substitute, you must use parentheses. parentheses are almost as important as that is word. Okay, so for z, we're going to put in 2/9. Can you already look at that and decide? Well, let's take a look. This is a negative. This is a positive. A negative times a positive is going to be a negative. So this does not solve it already, but look, we're here. Let's finish it up. 2 goes into 2 once, 2 goes into 2 once, and we get negative 1/9 equals 1/10. So that is no. 2/9 is not a solution because it does not make the equation true. All right, so just plug it in, do the math, do the arithmetic. All right, let's take another one. There's so many different ways you can get a question, but you're doing the same thing every time. Okay. Negative 3/4 quantity squared. Okay. Remember that the exponent only works on what's to its immediate left. So if this 2 falls, it will fall on the parentheses. Means that whole thing is being squared. So we have negative 3/4 times negative 3/4. Again, take care of the sign. The signs are the same, so it's positive. There's nothing I can reduce, so I'm just going to multiply straight across. 3 times 3 is 9. 4 times 4 is 16. So we get 9/16. All right? This next one, if you're into cooking, by the way, I am not. I'm into eating, but I'm not into cooking. All right, so the next one, number 4, you have 1/3 of a pound of butter. You have 1/3 of a pound of butter. You know I'm going to have to do this, right? You know I'm going to have to get you 1/3 of a pound of butter. Okay, 1/3 of a pound. Okay, here's 1/3 of a pound of butter. 1/3 of a pound of butter, and you want to make half the recipe. Whoops. A recipe calls for 1/3 of a pound of butter, but you want to make only half the recipe, which means we have to take half of 1/3. Half of this. This is your 1/3 of a pound. We have to take half of 1/3. Well, if we're taking half of 1/3, that means we're multiplying 1/2 times 1/3, which equals 1/6. So a half of 1/3 is a 6. Now you know what's coming, right? You know I have to prove that to you. Okay. If a half of 1/3 is 1/6, that means this 1/6 should take up half of it. Well, it doesn't stick on, so you got to play with me here. These two make up the whole. Oh wait, I can do it right underneath. That was silly. Okay, there's half, and 2 will make the whole one. So that means 1/2 of 1/3 is 1/6. Okay, so a half of 1/3 is 1/6. The next one, my favorite question. Okay, so let's look at Janice. Janice bought 12 tokens, and she's given 1/3 to her brother Sam. So we want 1/3 of these tokens, or 1/3 of 12. Remember what the denominator tells you. The denominator tells you how many equal groups you have. So we want 3 equal groups. Okay, so 3 equal groups. We're going to take these tokens and put them in 3 equal groups. So let's do that. Okay. There's one group. There's my second group. There's my third group. There's your 3 equal groups. What does the 1 tell me? The 1 tells me means I want one group. So if I want one group, I want this group, let's say, so I want 4 tokens. That's what that means. 1/3 of 12 is 4, because I want 3 equal groups and I want one whole group. I'll prove that to you. 1/3 of means to multiply. I have to write the whole number as a fraction. 12 divided by 1 is 12. Well, the only thing you have to do to make a whole number or a natural number a fraction is to put it over 1, and now I can reduce. 3 goes into 3 once, 3 goes into 12 4 times. 1 times 4 is 4. 1 times 1 is 1. 4 over 1 is 4. Good thing, because otherwise I had no idea how to do that problem if I didn't get that answer. So the answer is 4, because I want 3 equal groups and I want one group of those 3 equal groups. Okay, so let's look at the next question. This next question, you go in a dinosaur world. I would not be going to dinosaur world, but okay, here we go. You got Stacy spent 10 hours at Gotta Ride theme park. Gotta Ride, get it? Forget it. Okay, because if you don't get it after I say that, then there's no use to keep talking, you know? All right, Gotta Ride theme park. She spent 2/5 of her time in dinosaur world. Okay, so 2/5 of her time is dinosaur world. Well, 2/5 of her time, of means to multiply, her time was 10 hours, is in dinosaur time, equals what she spent in dinosaur time. That's what we're looking at. That's what that question is really asking. Okay, we're going to do this problem, and then I'm going to kind of map it out for you. Okay, here we go. I'm going to reduce. 5 goes into 5 once, 5 goes into 10 twice, 2 times 2 is 4, 4 over 1 is 4. So 2/5 of 10 is 4. Let's see why. If I have 10 things, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, that represents her 10 hours, let's say. Let's say that represents her 10 hours. I want 5 equal groups. If I want 5 equal groups, I'm going to have to, here we go. Here's group 1, here's group 2, here's group 3, here's group 4, here's group 5. Here's 5 equal groups. This group has 2 in it, this group has 2 in it, and so on. But this tells me I want 2 groups. So I want 2 groups of 5 equal groups. That's what we're saying. So I want 2 groups. So here's 2 groups. And how many are in 2 groups? 1, 2, 3, 4. That's how we get that 4. So that's all that's saying. Okay? This is the number of how many equal groups. This is how many of them we want. Okay? So let's do another problem. All right. I won't illustrate for you anymore. You try this one. This next one says, Kyle spent 8 hours at the park. Okay. He spent 3/4 of his time on the swings. So we want 3/4 of his time on the swings. Okay. How many hours did he spend on the swings? So we want 3/4 of his time. 3/4 of means to multiply. His time was 8 hours. Now I get to multiply. 4 goes into 4 once. 4 goes into 8 twice. 3 times 2 is 6. 6 over 1 is 6. I'm really glad I didn't get 4 because we kept getting 4. I kept thinking you'd always think the answer was 4. All right. So 6 hours on the swing. I want to know if that's consecutive time because I'd be throwing up by now. Anyway, 6 hours on the swings. Okay, so let's take a look at this. 5x over 6 times x over 10. Now, we can reduce just like we did before if we can. I don't know if we can or not in this example. Before we get real comfortable, until we get real comfortable with reducing, especially with variables, I'm just going to always multiply across. To be honest, because I could reduce here if I wanted to, but I'm not going to bother. Okay? I'm just going to multiply straight across. So this is 5 times x times x. X times x is x squared because that's what x squared means, x times x. Then 6 times 10 is 60. Once I multiply, remember now I can try to reduce. So I can reduce 5 and 60. 5 goes into 5 once. 5 goes into 60 12 times. So this is 1x squared over 12 or just x squared over 12. So again, until we get real comfortable reducing, I'm just going to work it out like that. All right, let's take a look at this. We're going to multiply across 8x. Remember, we could write x8, but that's kind of funky. We want to write the coefficient in the front. All over 12 times x cubed is 12x cubed. Now we're going to reduce. Now you may know how to reduce this a different way, which is fine, but I'm going to go step by step. This is 8 times x on the top. On the bottom, this is 12 times x times x times x, because that's what x cubed means, x times x times x. Now we're going to reduce. 4 goes into 8 twice. 4 goes into 12 3 times. Good night, x. Remember to write your 1. X goes into x once. And we get 2 times 1 on the top, or 2. 3 times 1 is 3, but x times x is x squared. Right? X times x by definition is x squared. So that's what I would do. If you know a shortcut, that's fine, but you may want to break it down like that. All right. Let's take a look at number 2. In number 2, we have a sign. I would take care of the sign from the get-go. A positive times a negative is a negative. Okay, now, whoa, look at that top. Wow. Look at all those letters. Almost looks crazy. All right. Now, 12 squared times x squared y. Really, all you're doing is writing it like this. W squared, x squared, y. The order really doesn't matter, though I would probably do it, yes, in alphabetical order. Same thing here, WY. I just like alphabetical order. And now we know we can reduce. How do I know that? Because there are same letters top and bottom. So here we go. Remember the negative, don't forget. W times X times Y. Thank God that doesn't say W to the 20th. If it said W to the 20th, we would have ran out of board space. But to be honest, we would have showed you something else. All over W times Y. Now watch this reduce. Good night, W. Good night, Y. So on the top, you have WX squared. And on the bottom, you have 1. So my final answer is just WX squared. Okay? I'm actually going to keep this on the board because I want to show you something. So I'm going to put number 3 up, and then we'll show you a shortcut if you can stand it. All right. Because if there were big exponents, this next way would be a little easier. So let's look at number 3. Okay. All right. We have a negative times a negative, so our answer is going to be positive, so I'm done with the sign. I don't care anymore about the sign. I'm going to multiply across. 4 times 10 is 40. A cubed B. All over 5 times 8 is 40. A squared, B squared. Okay? Now I'm going to try to reduce it. So this is 40 times A. You know what? Let me go underneath there so I have enough space. 40 times A times A times A times B over 40 times A times A times B times B. Okay, now we're going to reduce. We'll start with the numbers. Now the letters. A goes in A once, A goes in A once, B goes in a B once, B goes in a B once. So on the top, you have 1 times A, which is just A. On the bottom, you have 1 times 1 times 1 times 1, which is 1, times B, which is B. A over B. That big thing came out to A over B. First of all, let me just say something. I could prove this to you. I'm not going to, but I could prove this to you by doing this. Picking a number for A, picking a number for B. I could plug it in here, so I could take 40 times that number cubed times that new number, divided by this, plug in an A and B. That will be equal to this if I plug in an A and a B. And we've seen that before. The big thing I want to show you is look at this. Let me show you how maybe you could see what's going to be left without doing all of this writing, all of this extensive writing. Okay, I want you to notice here. Remember, these exponents here are 1s. Okay. Well, we have a W squared here, and we have a W here. So that means that if I'm going to reduce, see how I can reduce 1 out? There's 2 on top, but I can reduce 1. So actually, all I have to do is subtract the exponents. 2 minus 1 is 1 will be left. Here, there's no x's in common, so I can't reduce the x's. Here, the y's, they are exactly the same, so they will just reduce. So the only thing I should have left is the 1w up top and the x squared. And there it is, the wx squared. Here, a cubed. This goes, of course, but now let's look at the letters. A cubed. There's 2 down here. There's 3 upstairs. So all I have to do is say I know I'm going to have leftover A's upstairs. How do I know it's going to be leftover upstairs? Because there's more upstairs. And I just subtract the exponents. 3 minus 2 is 1. So I know I'm going to have 1 left upstairs. Okay, and again, you don't have to do this. I just want to show you if you see it. Okay, there's a 1 here. There's a 2 here. If I reduce, where do I have more B's? Downstairs. So I'm going to have a B left over downstairs. How many B's? Well, 2 subtract 1 is 1B downstairs. So I can actually go right from here to my answer once I get really good at this. And we'll see a lot more of that in the next course. But I can just subtract my exponents when I'm dividing. And where is that letter left? Wherever I have more of. So if I have more A's upstairs, my A stays upstairs. I have more B's downstairs, my B stays downstairs. So that's the end of multiplying fractions. Now we're going to go to dividing fractions.